In this tutorial, how to check given number is prime number or not. Prime number is a number which is not divisible by any other number from 2 to n minus 1. For example, 3 or 5 or 7, these are the prime numbers. From 2 to is 2 only. 3 is not divisible by 2. And let's take 5. 2 to 4. 5 is not divisible by 2 or 3 or 4. Similarly for 7, 2 to 6, not divisible by any of these numbers. So that number is called prime number. Let's write a function for this. Static boolean is prime int n. For or if n less than or equal to 2, return false. If for int I equal to 2, I less than n, I plus plus. If that number divisible by I equal to 0, return false. Otherwise, return true. Right? Let's check system.out.println is prime 3. Let's copy. Seven, 5. Let's compile it, execute it. Successfully execute it. True. 3 is prime number, 5 is prime number, 7 is prime number. Let's take 10. See, for 10 it is displaying false because 10 is divisible by 2 and 5, that is from 2 to 9. This number should not be divisible from 2 to n minus 1. Here this is how we find a prime number. If you want to find out number of prime numbers within a given range, in that case range int n1 int n2. Range of prime numbers. For int I equal to n1, I less than or equal to n2, I plus plus. If is prime n is, if it is prime returns true, that means that number is prime number. Or you can use printf percentage d is prime. Right, let's find out between range is wide, ten and 20. Suppose how many prime numbers are there between 10 and 20? There is a problem here. Printf. Let's compile again. Here it shows n not I. I is supposed to put see between 10 and 20, 11 is a prime, 13 is prime, 17 is prime, like 19 is prime. Is 19, I equal to 19 is prime. How many numbers? 1, 2, 3, 4, 4 numbers. Similarly, you can find out between the range 50. Let's put some space here. Eleven, 13, 17, 29, 31, 37 up to 47. If someone asks you to write display first 100 prime numbers, in that case how will you do? Display first display prime numbers int equal to count. In that case, we need to run infinity loop if is prime I equal to true, then system dot out dot printf same thing, I equal to or percentage d is prime number, comma I. Here let's press I. At some point of time, let's say if user asked for display first 100 or 50, in that case you need to have a counter int c equal to 0 if this is okay, if count equal to I, then break the loop. You don't need this also, because this variable is here, right? Declare I equal to 1. That's it. Display first 100 prime numbers. Suppose first are 50 prime numbers. 50. Let's see. Compiled successfully. Let's keep on displaying. We will put some message here. Out println displaying first 50 prime numbers. Let's compile it. Your problem here is you are passing I, that I 1 is not a prime number. We need to pass this 3 onwards, it works out. Count is here. We need to have another counter, int prime count equal to 0. If that number is a primary number, then only increment it. Okay, if this prime count is equal to count, in this case 50 we are asking, in that case here we need to pass the values from 1 to, we don't know, just keep on incrementing. If our count and this count equal, then only loop will exit. Here just display the numbers and /m. Let's compile it. Error. See, displaying first 50 prime numbers, 3, 5, 7 and up to 233. So that means 3 to 233. So first prime numbers you need to loop through almost all 233 times to get a first 50 prime numbers. Let's display first 100. So loop should continue for 547. See, 547 times this loop has to be executed. Here list of first 100 prime numbers. See, 199. Right. Now here is prime. If you take any number like 7, for example, it says 2 to n minus 1. That means 2 to 6. Any of these numbers should not divide 7, right? And also 7 by 2 gives us 3. After 3 or 4 or 5 or 6, it cannot divide this any number of the values. After that, no value can divide any number. So instead of putting n here, you can put n by 2 also. It should be equal. Only numbers just of that number can only divide that number, right? Some people write square root of 7. So you can put n by 2 here or square root of 7. These two conditions you can try here. Let's try now. See, you get same results. Even if you put n by 2 also, you get the same results. Let's try with the square root. Math.sqrt n. It should be equal, less than or equal to. Let us remember that, otherwise you will get see, even square root also gets the same values. First of 100 prime numbers, 3 to 547. That's it.